Hello all. Today we are going to study what is solvent extraction, what is the principle behind solvent extraction, and what is the theory or the mechanism involved in solvent extraction. So this was the only unit which was left pending for you MSc students. So we shall begin with solvent extraction. Why do we need solvent extraction and what are the types of solvent extractions? So there are basically two types of solvent extractions. One is liquid solvent extraction and the other one is solid liquid solvent extraction. If you all just remember the way in which you prepare coffee or tea. So you're going to use hot water and either you're going to add tea leaves or coffee powder to it. So here from the solid particles you're going to get the required constituent extracted into hot water. This is called as solid liquid extraction. For the final year MSc students, we had done an experiment wherein we had isolated nicotine from tobacco leaves. So when we did extraction of nicotine from tobacco leaves, if you all remember, we had used petroleum ether and aqueous alkaline water solution in which we had extracted tobacco. We should not forget that nicotine was soluble both in alkaline medium as well as in petroleum ether. So this nicotine goes on distributing itself between the organic phase and the aqueous phase. So this distribution is not uniform. So if we are dealing with organic compound, the organic compound would like to stay more in the organic phase, and if we are talking about ionic compounds, the ionic compounds would like to stay more in the aqueous phase. So depending upon what we are extracting, the solute will have more preference towards the respective solvent. Here, while we extracted nicotine, the nicotine was an organic compound and it will obviously like to stay more in the organic phase. So we have to do extractions wherein we are going to take organic phase and we are going to take the aqueous phase. Now there is a theory here. Here Nern's distribution law holds good. Since we are distributing the solute particles in both organic and aqueous phase, the distribution coefficient D will be equal to concentration of the solute in organic phase divided by concentration of the solute in aqueous phase. And the weight which is extracted from the aqueous phase into the organic phase is given by Xn is equal to XAQ into dVAQ divided by D into VAQ plus VOR to the power of N, where XAQ is the weight of the solute in aqueous phase, Xn is weight unextracted remaining in the aqueous phase, and D is the distribution coefficient, V is volume of the aqueous phase, VOR is the volume of the organic phase, and N is the number of times this extraction has been carried out.